An object of mass 3 kg rests on a plane. The coefficient of static friction and that of kinetic friction are given by coefficient of static friction 0.3 and coefficient of kinetic friction 0.2. The plane is inclined at an angle theta to the horizontal. Find the maximum value of theta for which the object remains at rest. We've solved that. So we are solving II. Find the acceleration of the object if it started sliding from rest. So I need you to know something. Whenever they ask you to find the acceleration of an inclined plane, it can be found in 3 ways. You can find the acceleration when the object is at rest. And when the object is at rest, we say that what it has is potential or you say static friction. That is potential energy, static friction. So at this point, you consider it to be frictionless. So you simply do force on x-axis equals to mg sine theta. Go and watch my video on inclined plane so that you say ma is equals to, or you say that is force on the inclined plane is towards the x-axis is mg and is at an angle mg sine theta, all equals to ma. Remember that f is ma x. So you can now do so that acceleration is equals to g sine theta. So this is when the object is at rest, or you say for a frictionless body. All right. Now, when friction is involved, when friction is there, that is when you're giving, or when you hear that the body starts moving downwards or upwards. So for a body moving downwards, first of all, you have force on the x-axis, which is weight on the x-axis, minus the friction now force, which is k, is equals to ma x. It's on the x-axis, you split all these things. Remember, I've taught you this. And the mg is at an angle to carry sine theta. The sine, we've done it. We've gotten this before. I don't want to start going over inclined plane, how to derive the dynamics. So this is mg sine theta minus fk. Remember that I told you that frictional force, kinetic friction, is equals to coefficient of kinetic friction times normal reaction. And from inclined plane, we got that normal reaction is mg cos theta. We've done all these things. Notice I'm rushing it because I don't want to start doing all the things we've done before. So we can divide both sides by m. So to find ax, so ax is simply mg sine theta minus coefficient of kinetic friction times mg cos theta all over m. That is what I will use when it's downwards, which means that for upwards, or you say that is trying to push the inclined plane, is not sliding downwards this time, but when it's sliding upwards, notice that as it's sliding upwards, there is a weight that is always acting this way, which is mg, that is at an angle, which is sine theta. And since it's being pulled this way, friction will be acting this way, and the friction when a body is moving is kinetic friction. So see that they are going in the same direction. So we simply have mg sine theta plus kinetic friction is, remember, coefficient of kinetic friction times mg, that is normal reaction cos theta, equals to max. So divide both sides by m. So that is what x will be. So ax, the acceleration on the x-axis when it's sliding upwards, will be mg sine theta plus So since the question here asks us to find the acceleration of the object if it started sliding from rest down the plane at the angle theta max to the horizontal, the formula we employ will be this one. So that I have AX equals to mg sine theta. If you go to your textbooks, you see they do a lot of arithmetics there that if you don't know how to do factoring out, find it confusing. So not to worry, you're going to be correct with this. It's the same thing over m. This is more accurate even. So AX, acceleration on the x-axis when it's sliding downwards will now be the first, the object has 3 kg mass. And we are using the standard G, which is 9.8. Sine theta that we got at maximum is 17 minus coefficient of kinetic friction is 0.2 times 3 times 9.8 cos theta all over 3. So all things working together, if you do this, you should have everything to be 8.5957 minus 5.6231 all over 3. So acceleration on x-axis will be equals to 2.9726 over 3. So this should be equals to 0.9 meter per second square, or you see acceleration on x-axis is equals to 1 meter per second square. So there you have it. Let's move to the next question. How long does it take the object to move from rest? So let's draw this. Let's draw the object. So I have this. I have the object that is 3 kg. And they are saying how long, in 10 years, how long is time does it take the object to move from rest? Okay. Under the conditions of II, that is moving down 1 meter. And meter, anytime you see meter, you know it's distance or displacement. S is equals to 1. So, and they're asking for T. So once I see this kind of question, it has entered kinematics. So I will simply employ the formula that has S equals to UT plus half AT square. Okay. So notice that this is at x-axis. So I'm using A. If I have an object this way, this side is the x-axis, this side is the y-axis. If it turns, this is the x-axis, this is the y-axis. So notice that it is from under the conditions of this. Remember that from this one it started sliding from rest. So U is 0 and times T, everything here is 0. So I just have S is equals to half AT square. So an S is given to me to be 1 half. Then my A, I got it to be, the acceleration there, I got it to be 0.9. Then T square. If you remember, T square. So before you go and start doing, replacing this with G, whenever they tell you sliding this way, there's acceleration on this, because this, even though it's bent on this object, it has vertical axis and as horizontal axis. The horizontal axis is where this thing is happening, the movement is happening, it's sliding down. So note that. So I have it's the same thing as saying 1 equals to 0.9 t square over 2. So times crossover, cross multiply, you have 2 equals to 0.9 t square. Divide both sides by 0.9. So you now have that t square is equals to 0.2 over 0.9. And you can actually take the square root of both sides, so that you have root 2 over 0.9 is equals to t square root. This will cancel this, so that t is equals to root 2 over 0.9. T is going to be equals to so if you do this right, you will be having, okay, wait. You'll be having 1.57, which is t is equals to 1.6. T is approximately 2 seconds. There you have it. Alright, so for your classwork, I want you to do this one for me. A body 3.5 kg on an inclined plane that is at an angle of 35 degrees. Find the time to get down this. That is the time it will take it to come down. And the speed at the bottom, the speed for it to get down. Okay, then we have another body 3.5 kg, 35 degrees, initial velocity 15. This one, remember, this one has height. How far will the block slide up the ramp? How far means s, the displacement. So get these two for me. So in summary, I did a summary here. I said, note, at rest, static friction equals to weight down the plane. Static friction is equals to Wx. And remember that static friction is very proportional to normal reaction. And on equality, introduce equality coefficient of static friction. So this is going to be this. Yes. So for case 2, for inclined plane, when the body starts sliding downwards, the body is moving downwards. As it's sliding downwards, friction, kinetic friction will be there going in opposite direction. So you have forward force, which is downward, minus the kinetic friction opposing, equals to everything, force of the system equals to mass and acceleration. So forward minus backward, force on the x-axis. So you have force on going forward is mg at an angle, and force on the x-axis, the mg is at sine theta. You can see it as something, if it's hanging, is abnormal. So for that reason, it's this way. So I don't want to start treating this. I've done it. To check my inclined plane video, minus the backward force, which is coefficient of kinetic friction is equals to n, direct proportional to normal reaction, is equals to coefficient of, that is, kinetic friction is equals to coefficient of kinetic friction times normal reaction, which is this. So if you introduce it, everything is equals to mx. So when the body starts sliding upwards, you see that as it's going upwards, as you are pushing it upward, friction will be acting in opposite direction, and there is gravity that is always acting to pull something down. So that mg is acting this way. So you can see that force on x-axis is acting in the same direction with kinetic friction. So you have plus to max. When you replace it with the values, you have this. So this is what you use to solve. Thank you. Remember to subscribe, share, and like.